Now we move on to presentation and analysis of SPAT speed data. So the data collected in SPAT speed studies are usually taken only from a sample of vehicles using the section of a highway in which the study is conducted. But this data are used to determine the speed characteristic of the whole population of vehicles traveling on the study site. So it is necessary to use some statistical method in analyzing this data. So there's several characteristics are usually determined from the analysis of the data. So actually for the presentation and analysis of SPAT speed data, it can be calculated directly from the given data, or others they determine using a graphical representation. So the data must be presented in a form suitable for a specific analysis to be carried out. So we have here a sample problem. Table 4.2 shows the data collected on a rural highway in Virginia during a speed study. Develop the frequency histogram and the frequency distribution of the data and determine arithmetic speed, arithmetic mean speed, standard deviation, median speed, the pace, the mode or modal speed, and the 85th percentile speed. So we are given here with a tabulation of the speed data obtained on a rural highway. So this is, we're given with the car number, and we have the speed for every vehicle, for each of the vehicles. So therefore, to prepare this one, we have to prepare a frequency distribution table. So this frequency distribution table, for this problem, we have to go back to our statistics. So we're going to make use of the concept of frequency distribution. So we're going to uh, prepare a frequency distribution table. So from this frequency distribution table, based on our learnings, we have to, on the first column, we have to identify our class range. Actually, class range that will, for this one, since we're talking about speed, this will be called as speed class. So we're going to have the range wherein you're going to have range from when to start. For the range, you have to identify the lowest value in numbers. So for this one, the lowest speed. So if we're going to refer to our tabulation for our given data, you have to search for the lowest speed. So basically from here, if we're going to observe our if we're going to have here the lowest speed, it will be based on this. You have here the lowest speed to be equivalent to, what will be the lowest speed? So you have to search for the lowest speed. And basically, you have here actually, which is equivalent to 35, I think. So this will be the lowest speed. You have 35, no less than 35. So it followed by 36. Then we have here 34. So you have the lowest speed, which is 34. So this will be the lowest speed, which is 34.8 actually. So based on this tabulation, the lowest speed is 34.8. So which means for your speed class or the class range, you're going to start with the lowest value, the lowest number, which is based on the given data, that is 34.8. So we're going to start with 34. So we're going to have 34, then you can have the range 34. So this class limit actually has a range value, which is interval of 1.9. So that will be start from the lowest, which is 34 to 35.9, then followed by, after 35.9, that will be 36 plus 1.9, so you have 37.9, and so on and so forth. When to stop? To stop, you have to identify now the highest possible value. So what will be the highest possible value? So for this one, what will be the highest value? What is the highest speed? So basically, you have to identify that one on your tabulation, and that will be the that will be how you're going to end up your class limit. So for this one, for your speed class, you start with the lowest value towards and you will end up on the highest value. After you have obtained now your speed class, you're going to have identified the second column will be the class mid value. So class mid value, you simply have the midpoint of this, the mid value. So 34 plus 35.9 divided by 2. Actually, the result is 34.99. So it's rounded up to 35.0. So all of those, you get the mid class value. On the third column, this will be the class frequency. So class frequency, actually, you have to identify based on the given data how many speed belong to how many numbers of speed belong to this class. So you have to identify. So for this one, for example, there are 2. So you count off that one. So that is 2. Then for this class range, for the speed class or class limit, the frequency, there are three vehicles that belong to this speed class. So you have to identify that one. So you have to refer to the given data, then you count off the number of speed that belong to this class limit or speed class. Then you try to up to the end, then you try to sum up. That will be called 2. That is the summation, which is 86. So which means 86, this is the total number of cars. So if it will not tally to 86, so which means there is an error, so you have to go back again. So it must tally to the number of cars. So based on our given data, so you have here the last number of car, which is 86. So which means that your frequency, as you sum up that one, it should be equal to 86. If it is not equal to 86, you have to repeat again your frequency, then try to refer to the tabulation to the given data so that you can make a correction to whatever error you made. Then you have the fourth column, which is f sub I. You simply have to multiply times u sub I. Then percentage of observation in class. So percentage and observation in class, you simply have to divide. So that's 1. That's 2 divided by 86. So that would be the result. 3 divided by 86, this, and so on and so forth. Then cumulative percentage of all observations, so which means that you have to copy for the first one, this cumulative 2.3. Then you sum up this one to that. So you have that 5.8. You sum up this, then you get 8.9, and so on, until make sure that the end will have a 100%. This is cumulative percentage. So the endpoints should be equal to 100%. Then for the last column, that will be u sub I minus bar u squared. So you have now the value for u sub I. You have to get the value for bar sub u. So you have the formula summation of f sub I times u sub I all over u sub I. So the formula to this actually is equal to the summation of f sub I u sub I all over summation of f sub I. So you get that value, then you try to substitute to our equation. So you have now the equivalent value for this one. So you're able now to present or your frequency distribution table. Now you have to draw your histogram. So for the histogram, you simply have to, on the y-axis, you have the vehicle speed. So you can have here, you can have your interval for your vehicle speed. On the y-axis, you simply have your frequency. So you simply have to pair up the vehicle speed with respect to observed frequency based on our tabulation for the frequency distribution curve, so that you can have now your histogram. Then afterwards, after you have drawn your histogram as well as your you have prepared your frequency distribution curve, you could now identify your frequency distribution. So frequency distribution, so basically this will be a graph of the vehicle speed with respect to frequency. So which means that you have to graph your vehicle speed with respect to the frequency based on our frequency distribution table. Then afterwards, you can have your cumulative distribution graph. For cumulative distribution graph, you simply have to graph the vehicle speed with respect to cumulative frequency. So the data to this is based on our frequency distribution curve. Then you can solve now for your arithmetic mean speed, which is actually for the arithmetic mean speed, you can have here our result, which is using the formula, which is mu bars of mu is equal to the summation of f sub I, u sub I all over summation of f sub I. You simply have to substitute the values, and you get now your arithmetic mean speed, which is equal to 49.5, which is in mile per hour. Then you can have the value for the standard deviation using this equation. You simply have to identify the value for summation of f sub I times u sub I minus our bar mu, which is squared. So we simply have now the value, which is 3,632 over n minus 1. So which is equivalent because f sub I, summation of f sub I is 86, so minus 1, you have 85. When you try to substitute, you get a value of getting the square root. You have now the standard deviation, which is positive and negative 6.5 mile per hour. So basically, you can have the value for your. So for our median speed, it can be obtained through our cumulative frequency distribution curve. So from here, uh, which is at median. We're talking about median speed, so which means at the middle part, so which means we have here the median, which is 50. So draw a line horizontal to that, then as it intersect, you draw a line downward. So you can read now the median speed, and approximately that is equivalent to 49 mile per hour. Then for the pace, you can obtain that one through our frequency distribution curve. For the pace, it can have an interval of 10 mile per hour, wherein it has the greatest number of observations. So based here on the greatest number of observation at an interval of 10 mile per hour, so it approximately, this is 45. So this is 55. So this is a 10-mile interval, and it has the greatest number of observation. Actually, this is based on the frequency. This is 11 to 11. So this will be our pace, which is from 45 to 55 mile per hour. It has a 10-mile interval with the greatest observed values. And for our mode or modal speed, that can be obtained through our histogram. So from the histogram, it can be observed that the mode or modal speed is actually 49. This is the modal speed. It has the greatest number of observation, which is actually equal to 49 mile per hour. So that is the value for our modal speed. And for our 85th percentile speed, it is obtained from our cumulative frequency distribution curve. So from the cumulative frequency distribution curve, you can identify your 85th percentile speed. So the 85th percentile speed, so you refer to our cumulative distribution. So on the y-axis, this is approximately 85th percentile speed. So you draw a line horizontal as it intersect with our cumulative distribution curve. You draw a line downward, then approximately you read the vehicle speed. So approximately that is equal to 54 mile per hour. There are applications of speed data that may require a more complicated presentation and analysis of the speed data. For example, if the speed data are used in research on flow theories, it may be necessary for the speed data to be fitted into a suitable theoretical frequency. So here it is also important to have sometimes necessary to determine whether there is a significant difference between the mean speed of two spot speed studies. So for this, for the comparison, you can make use of our standard deviation of the difference in mean. So you make use of this equation, and wherein our n sub 1 is the sample size for study 1, our n sub 2 is the sample size for study 2, and s of d is the square root of the variance of the difference in means, and s1 squared is the variance about the mean study for study 1, and s2 squared is the variance about the mean for study 2. So this is being used to, the standard deviation formula is used for, we wanted to compare the difference between the mean speed of two spot speed studies.